Psychology. What do we think of when we think of psychology? In pop culture, we tend to have this impression that psychologists can read minds or study horoscopes, blood type, or MBTI. We usually don't associate psychology with sciences such as math or chemistry. Unlike those natural sciences that study things in the physical world, we get to study things in our minds that we can't actually see. So in the early stages of psychology, it was claimed to be a subject of pseudoscience. But as of today, psychology is a field of science that can be compared with biology and physics, all because a very useful tool is adapted and makes psychology a reliable and valid field of study. That tool is statistics. Psychology is about people, and statistics can help us extract data from a sea of people and make sense of the results. By doing this, we can translate human behavior into meanings and information we need to know. Through the process of statistics, we can be sure that the results we get is objective and scientific. The application of statistics redeemed the place psychology has now in the field of science. So today we're going to be talking about 4 main topics in statistics and how statistics work in the research of psychology. We've actually learned some statistics in math class in high school. Let's actually do a quick review, shall we? First off, we have measures of central tendency, which includes the mode, the median, and the mean. Statistics like these tell us the position of most of the data points. The mode is the most common value in the data. The median is for the number in the middle position when put in order, and the mean for the sum of all the data values divided by the number of data points. We write the mean as x bar. Then there are measures of variation. Measures of variation describe how the data points scatter with respect to the mean. The most common measure of variation is the variance, calculated by adding the square of the distance from all data points to the mean divided by the number of data points. We note it as x squared. There is also the standard deviation, which mathematically is the square root of the variance, which makes it written as s. It stands for the typical distance the data points are to the mean. We also learned from high school that if we have 2 sets of data, we can find out the relationship between them by acquiring the correlation coefficient r. And the linear regression statistics B1 for the slope of the regression line and B0 for the y-intercept of the line. These are important numbers when we look at data in psychology as well. It is a great way to summarize and have insight of the information we gathered. Did you notice that the notation of the same statistic is sometimes different? Like both the letter S and sigma is for the standard deviation. Well, in high school, we can usually use them interchangeably, but it is a very important distinction in psychology and educational statistics. The Greek letters refer to the population of interest. Well, almost always, the population is too hard and too large to research at the same time. For example, if you're interested in how well high school students in Taiwan speak English, then the population is all high school students in Taiwan. We cannot gather information from all the students in Taiwan, so there is sacrifice to be made. We pick out some of the students and study them instead of the whole group. This process of picking people out is called sampling, and the results of which is what we call a sample, which is just a group of people. The English alphabet stands for statistics attained from such a sample. The sample should always be a subset of your population. That means all members of the sample should also be members of the population. The goal of studying a sample is to infer what the group of interest, or the population, is like. And we often use the statistics of the sample to infer the parameters of the population. From the example before, if you're interested in how well high school students in Taiwan speak English, you can select about 500 students. By measuring these 500 students, we can know how well the sample students speak English. Then we can estimate or guess the English ability of all high school students in Taiwan. The relationship between the sample and the population is the core of statistics. By sampling a population, we can understand ourselves in a more efficient way. If we want to understand how statistics can help us in research of psychology, we could dig deeper into the 4 main topics in statistics in psychology and education. Descriptive statistics, inferential statistics, hypothesis testing, and correlation and regression. Descriptive statistics, as the name suggests, it is how we describe the data. Once you've gathered data from a research or survey, the first step is to organize and make sense of the messy pile of data. We don't just want data, we want information. So psychologists agree upon a system to describe what information we can obtain from the data. Such information is what we learn in high school, most prevalently being the mean and the standard deviation. For example, if we are interested in the English ability of recent high school graduates, we administer English tests in high schools and get the data of 10,000 students. It would be useless to leave the data as it is because it is just a random set of 10,000 data points. We can calculate and summarize what we can see in the data. For instance, if we process the numbers so that the mean of the test scores of these 10,000 students is 50 out of 100, the information tells us that the scores of these students are around 50. And if we know the standard deviation is 10 points, statistically we would conclude that only about 10 people can score more than 80. The mean and the standard deviation are classic examples of descriptive statistics or useful information. It condenses the meaning and information we can extract from the raw data. So the descriptive statistics convey information. The second topic is inferential statistics. Inferential statistics take things much further. When we do statistics, we want to go beyond the data itself. The data comes from the sample, but what we care about is the population. We want to study not only the people we picked out, but all the members of the group of interest. Again, let's do an example. We are interested in the IQ of all 400,000 high school students in Taiwan. And we don't expect to give all students an IQ test, so we decided to pick 10,000 students as a sample out of the population. We gathered 10,000 students to do an IQ test. Inferential statistics can tell us the relationship between the 10,000 students we picked out and the 400,000 students we want to know the IQ of. By the mean IQ of the sample, we can infer the population mean. By the standard deviation of the 10,000 students, we can estimate the standard deviation of the 400,000 students. Just like that, we use inferential statistics to connect the sample and the population and infer the parameters of the population. By inferential statistics, we can extend the results to the whole population and estimate what it's like. So inferential statistics estimates the population. Next, one of the most important feats of statistics is to tell us the probability of a conclusion being right or wrong. Well, that is the job of hypothesis testing. In psychology, we are also interested in the development of children, so we're going to do an example of that. For example, if we are interested in how well elementary students can use logic, we guess or hypothesize that 6th graders could use logic better than 4th graders. This is our belief and is the result we hope to get. Well, here's a fun fact about statistics. We use it to disprove something rather than to confirm something. So we can come up with an opposite hypothesis and then try to prove it wrong using statistics. So we flip the original hypothesis upside down so that proving it wrong is proving us right. Our hypothesis will be 10-year-olds can use logic as well as 12-year-olds. It is called the null hypothesis, the hypothesis that we wish is false. But without rejecting it, it is always assumed true. Hypothesis testing is a statistical process to test if we can reject the null hypothesis. That makes the original belief supported. The original belief is called the alternative hypothesis. In this case, the alternative hypothesis is that 10-year-olds cannot use logic as well as 12-year-olds. By statistics, we'll never be sure 100% certain if the two groups are the same or different. Our results will tell us the probability that these two groups being different. In psychology, if we're 95% sure that these two groups are different, we are confident that they are different. Otherwise, we will say that these two groups are not significantly different. Based on the level of certainty we have regarding the difference between the two groups, we can further associate this with our null hypothesis. We could either reject or not reject the null hypothesis. From our prior example, if we calculate the results and we are 95% sure that 6th graders perform logic better than 4th graders, then we reject the null hypothesis. That is It is almost surely false that 10-year-olds can use logic as well as 12-year-olds. When we reject the null hypothesis, we simultaneously accept the alternative hypothesis that 10-year-olds cannot use logic as well as 12-year-olds, since the two hypotheses are the exact opposite. On the other hand, if we're only 30% sure that these 4th and 6th graders are different, we cannot reject the null hypothesis, nor accept the alternative hypothesis. In this case, our result will be we cannot reject the idea that 10-year-olds can use logic as well as 12-year-olds. Statistics used in this way can help us be confident in phenomena and solutions, to help us detect and throw away claims with weak evidence and keep the strong ones in psychology. So, hypothesis testing investigates and filters information that enters our field. The fourth and last topic in statistics in psychology is correlation and regression. We can use correlation and regression when we have two or more concepts or groups we need to compare. We gave birth to a tool, Pearson's R, the correlation coefficient. We know that the absolute value of R ranges from 0 to 1. The larger the absolute value, the more related the two groups are. It doesn't even have to be people. Correlation can also tell us how related two concepts are to each other. In psychology, we pay very much attention to our mental health. We have a lot of research regarding two crucial concepts, depression and anxiety. We know that these two are closely related, but we don't know how close, and if we can predict one with the other. Correlation can answer one of these questions. We can make a scale to measure the depression levels, and make another one to measure anxiety levels, and see how closely related the answers of the two scales of the same sample are. If the answers to the two scales have a correlation coefficient of 0.6, then depression and anxiety are moderately correlated. But this provides no evidence that anxiety causes depression or the other way around. It just means that they usually co-occur. For the matter of causation, when we need to verify whether A causes B or B causes A, we would use a regression model to analyze it. Let's reuse the example from before, but we will add another concept that we are interested in, which is suicidal behavior. As psychologists, some of us are eager to find out what causes suicidal behavior. We guess it might be depression. So we decide to come up with a formula where when we know how depressed a person is, we can predict how likely he is to commit suicide. To do regression, we draw an XY plot with levels of depression as X and the amount of suicidal behavior committed as Y. We can draw a line that represents these data points called the regression line. The slope of the line is the regression coefficient. Because I know the slope of the regression line, I can put in the value for X and be confident that Y is within a certain range. By this, we can successfully predict suicidal behavior by depression. Of course, the model used to study depression is way more complicated than demonstrated here, but it's a gist of what is happening in statistics. So, correlation and regression connect and relate different concepts or people in psychology. What else is there to psychology? We study personality, for example, to predict a person's typical behavior. We study people under social influences to understand why people would behave differently when alone and when with a group of people. We study different senses, vision, hearing, smell, taste, touch, and to make sense of how we interact with this world. We study people with extreme and abnormal emotions or thoughts. We study people's growth from childhood to old age, and we study the structure of the brain and how it makes us feel, think, act, and desire. All of these happen in the brain, and not the outside world. They are very difficult to prove directly, even if we cut open a person's brain. And science is all about proving. Proving what you say is true, proving how the world is what you say it is. So, psychology had not always been considered a science, but that was before statistics came in. Statistics came into psychology and changed psychology forever. Statistics is objective, mathematical, and scientific, and statistics in psychology is revolutionary. Statistics is why we are confident in what's right and what's wrong. It is how we prove what human beings are like. It makes psychology a science without political or religious influence, just like how chemistry and physics could prove how the world exists, we could prove how the mind exists. All thanks to statistics, it makes psychology more practical, responsible, and resourceful. Without it, psychology would never be a field of science. It could never reach the level of abundance in research as it is today, and nobody with a sound mind would even care about psychology if it were not for statistics. So, when you pick up the heavy textbook, be respectful, because it carried over 200 years of effort of psychologists striving to make things work. And it is a blessing we could fit all that in a 500-page book for all the world to see.